Okay, let's go over the difference between all the types of equations that we learned. Okay, so arithmetic means that we're going to add or subtract. So no matter what type of equation we make, we need to have an adding and subtracting pattern. Okay, whenever it says recursive, that uses the previous. Okay, and the previous is going to be represented with f of x minus 1. So the equation for arithmetic recursive is going to start f of x equals, and then we have to take the previous, and we have to either add or subtract a pattern. So it's going to be plus or minus some sort of common difference. Now that common difference could be in the front or it could be in the back, but we're going to see some sort of pattern. We're also going to see things like f of 1 equals starting number. Okay, so they're always going to give you a starting number with recursive to get you started. Okay, so these are a couple of key things you want to look for. Then you know it's recursive. The plus minus means it's arithmetic. Now for explicit, the equation is going to look a little different. It's going to be f of x equals, and then you're going to have some sort of starting value. And then you're going to have, let's use teal again, you're going to have that common difference. So plus or minus the common difference, okay? But then you're always going to have your variable right here, x, and that could be x plus or minus a number to take it back to 0. So your input variable is going to go right there. Okay? Now, if it's geometric, let's just separate our paper a little bit. If it's geometric, you're going to have a multiply, okay, or a divide pattern. Remember, divide is just multiplying by a fraction. Okay? If it says recursive, we're still going to use that previous, which is f of x minus 1. So what does a recursive equation look like? It's going to be f of x equals take the previous, okay? But then you're going to multiply, by the common ratio. Okay, and that could be multiplied by 1/3 if it's divide by 3. And remember, with recursive, they're always going to have to get you started. So you're going to see f of 1 equals starting value. Okay, so if you see multiply and you see that recursive, that previous term, then you know it's geometric recursive. What does the explicit formula look like? I'm going to put this down here. Okay, so f of x is going to have the starting value. So you have your starting value. Now, since it's geometric, you're going to be multiplying here, okay, by the common ratio. Because it's geometric, you have to have multiply. And then you're going to have a power. You're going to have an exponent. And the exponent's going to be your input variable, x. But then it could be minus 5 to take it back to 0. Okay? So let's take a look at a couple examples and see if we can determine what type it is, and then what kind of sentence you'd want to say for explaining. Okay? How do you know this is arithmetic? Okay, how do I know this is arithmetic? Well, arithmetic means adding or subtracting. So I could see right here, this is the previous. That's previous, okay? And right here it says minus 2. Okay, so this is a subtracting. It's a subtracting 2 each time pattern. And since it's subtracting 2, that makes it arithmetic. Okay, this one's also recursive. Let's take a look at number 2. How do I know this one is geometric? Okay, geometric means it's a multiply or divide pattern. I notice here that it starts with 18, okay, and we have a 1/2. So I know it's geometric because the common ratio is multiply by 1/2. Okay. I also up here could have said subtracting 2. I could call this the common difference. Okay, because the common difference is subtracting 2. Okay. How do I know this equation here is explicit? Okay, so explicit means that there's a formula where you can plug in any value. Okay, I don't see previous. I don't see previous. I see that the input is x and the input here is x. So I know it's explicit because we can plug in any value of x. Okay, and I'm also going to add here in brackets, okay, we are not using the previous. We're not using the previous. We can plug in any value of x. That's what makes it explicit. Okay, number four. How do I know this function is recursive? Recursive is, I think, one of the easier ones to spot. Okay, right here, g of n has g of n minus 1. Okay, when I see that function but one input less, okay, I know it's recursive because it is using the previous term. Okay, I can't find g of 100. I have to know g of 99. Okay, so previous is the good word to use when you're explaining recursive. Okay, which function here do you think would be better for finding the 99th term? Okay, so I'm noticing right here, this function is recursive. So what this function says is take 4 times the previous. So for me to find the 99th term, all I would do is take 4 times the 98th term. Okay, but I don't know the 98th term. I know the first term is 5, and the second one would be 4 times that, so the second term is 20, and then times 4 would be 80. Goodness, I really don't know how I'm going to get the 99th term without knowing the 98th term. We do not know the 98th term. Okay, so this is going to take me forever. Let's examine this explicit equation here. For me to find the 99th term, all I would have to do is f of 99. So I could take the input, that should say x right there, and I would plug in 99 minus 1, and then I would just use my calculator here to figure out what 5 times 4 to the 98th power makes. I think this is the way to go. Okay, I think this function is better for finding a term that's far out because I can just plug the input in. Okay, so the explicit function is better for finding any term. Okay, I hope this helps you identify your functions better.